All right, so we have this guy named Euler. He made this, and notice that he used the word elegant. I think that's kind of funny. An elegant way to determine the validity of arguments whose premises contained all, some, or no. Okay? Those types of statements are not easy to do with a truth table, so he came up with this other way. Euler is kind of a cool guy. He was a prodigy. He was the Shakespeare of the math world. He wrote hundreds of books and papers on math. So he was an Energizer bunny of math. Okay? So what I need you guys to do is, in your notes, write all this down. There's 4 different types. All A are B. An example of that, I like to consider myself as a nerd. I always have been. So you could say all nerds are awesome. Okay, so that would be in that first case. The second one is no A are B. Okay, so an example of that, no dogs are cats. They're not related except for the fact that they're mammals, right? The third diagram is some A are B. Do you guys remember what the definition for some is? Some is not all, but specifically. It means at least one. And notice that there's a dot in the middle of that. Some A are B. So there's at least one person or one thing that's in that region of that diagram. And the other one is some A are not B. And that would be an example there, where it would be in this region of the diagram right here. Okay, so I would like you guys to write down this. Basically, it's just saying how you go about deciding if an argument is valid or invalid by using Euler diagrams or arguments, okay? The first one is you're going to make an Euler diagram for the first premise you see. Don't go on to the other ones, just look at the first one. Okay, step 2 would be adding to that diagram with the second premise. And the last step says the argument is valid if and only if every possible diagram illustrates the conclusion of what it says.